to remember we were running still, had the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand, open arms. This is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadows in the trees, holding on, memories never change.
Good evening, everyone. Okay, it seems to work, at least I hope it works. Let's see if it works. It was a long time before I streamed last time, wasn't it, right? So, nice to see everyone again. Well, I actually cannot see you, that's unfair. But I do see people on chat, so hello everyone on chat. And hello also to everyone who is actually watching this video as a recording afterwards. So today's moderator will be KrzaQ as usually, though not as in the last 4 streams, which were actually done by Honorary Bot. His series is now over, so you can find them actually archived and on my channel. So he did a great job. I was like really enjoyed working with him, so I'm really happy about that series. Yeah, but now back to the usual program, or actually back to a rather relaxed episode about missions, because I didn't do any mission solutions in the last couple of live streams, right? Because I didn't want to take time off what Honorary Bot could show. So I decided to make an episode just about missions. I will actually try to solve the missions which I created. I obviously created all of the missions, so I do know, somewhere in my head I do remember the solution. That being said, I did create them 2 months ago or something, so it's not like fresh knowledge. So I will probably like try some different things until something works. So that's that. Now, yes, if you have any questions at any point in time, then do ask this person. Again, KrzaQ or KrzaQ KQ on IRC or YouTube chat, and he will let me know using a telepathic connection we have with each other. Actually, KrzaQ is just a voice in my head. I sometimes think that. Yeah, anyway. So, yeah, on like announcement part, I guess in this stream everything will be as it was in the usual series. Now, that being said, I am going to make some changes because in a couple of last live streams I did the news part, and the like announcement part actually took like half of the stream, and then I had like, I don't know, 45 minutes left of actual technical content I could do. So I decided that's not really where I want to be. So probably the mission solutions presentations as well as part of the announcements will be moved to separate videos, like, you know, video blogs or whatnot, however you want to call it. That will not be the part of a live stream, but you can still find them on my channel, so the content will be there, just not as the part of Wednesday's live stream, which I'm doing. Similar changes will be made on the Polish live stream, I guess, some time in the future. Now, okay, let's go to the usual stuff then. The shoutouts will stay here, because I do think that is really worth shouting out to. For example, KrzaQ, oh wait, do I have... yes, I have this. I was wondering if I have like Zoom it actually turned on, but I do. Yeah, so for example, you might want to check out KrzaQ's website, which is dev.krzaq.cc. That probably wasn't the best underline I ever did. And from time to time, he actually does post on his blog, and if you're into programming, especially C++, you probably want to check it out. Then you probably want to check out Live Overflow's channel, especially that now he has like 2 to the power of 5 subscribers, if you only count what is before the comma, obviously. Otherwise, it doesn't work out. It's like closer to the power of 15, right? That being said, do visit his channel if you're into security and into CTFs and so on. So, yeah. And another announcement is actually, and another shout out is to Mormus, who is also doing live streaming of security stuff and CTF stuff. And he will actually also have a live stream today after, I think just after my live stream. I think that's what he said on Twitter. So do check out his channel. He probably has it already scheduled. And he has some fun stuff there going on, especially like exploiting a vulnerability in IE for Windows 95. That's really awesome. That's really fun. Now, to move to some like why was I away? Why there were no streams for the last 2 weeks? I was basically traveling in Poland. For example, I was book signing. So this is what I do when I'm traveling, like book signing. Because while I didn't publish any book in English yet, I did publish like one book in Polish, and then I was like co-author / editor of another one. So yeah, I usually do that. Apart from that, I also went to a retro pixel shop, which is like basically a shop with old hardware. I bought myself a game on like a Commodore 64 cartridge. And I also went to a museum of old computer games and old computers basically as well. The museum wasn't opened yet. It like was opening in a couple of days, but they actually showed me around. So thank you for that. It's in Breslau, in Wrocław. So if you're there, like visited, they have some amazing hardware. For example, they like actually set up a Vectrex console for me, which is a console from 1985, which is like the only console I actually know which does drawing not pixel by pixel as a bitmap, because you know, like this, for example, this image you're seeing is actually displayed as a bitmap, but it's drawing by, you can actually move the spot around the screen, the illuminating spot from the CRT monitor, to tell it where to go. It doesn't go scanline by scanline, you just tell it where to go. So it's basically like the only real vector console or graphic display I ever saw, apart from oscilloscope, of course, like the typical old ones. And it's quite amazing. I mean, you get some free operations there which are not possible on bitmap graphic displays, but you lose, for example, colors due to that. So yeah, some fun stuff is going on also in KrzaQ. It's in KrzaQ in Poland, but it's actually also for international community, so I thought I'll mention it. It was on my blog as well. It's called Hackathon, and it's actually a huge hackathon, and they try to, I think, break a record of how many people actually participate in the hackathon. It's going to take place in Tauron Arena, which is a rather huge stadium. Do they have a picture of it? Please, picture. No picture? Oh, come on. I guess there is no picture. Oh, gallery. Perfect. Yeah. It's like... Is there any like a huge picture I can actually show? Yeah. Well, that's like just half of it. No, even not a half of it. It's a huge stadium. So there will be a lot of place, I guess, for hacking. And the topic of the hackathon is going to be extreme living, however you want to interpret it, but it's like something like around extreme sports, I guess. So if you like programming, if you like hackathons and compost and stuff like that, then it's in KrzaQ. It's actually pretty cheap, like $18 to participate per person. And it's happening late October in KrzaQ, so check it out. Apart from that, I did publish like so I get asked questions a lot, and there are questions which are being repeated quite a lot, and for example, one of them is how to find vulnerabilities. So I made an answer post with like, oh, this is how you find vulnerabilities. It's obviously like a high-level post, but it is a couple of pages of reading, so do check it out if you're interested. I'm half finished writing a post to answer the question of how do you get into reverse engineering, how do you start, and what do you do. So I'll publish it probably this or the next week. So there is a question, what was my book about? So yeah, what is your book focused on? So the book which I published is basically like a programming book, but it's not for beginners. It's not a specialized book. It's a book for the intermediate and upper intermediate as well. So it touches on a couple of subjects. It's actually about C++, Java, Python. It's about like the common themes in them, but about from a low-level perspective. The book is, by the way, translated already into English, but I do need to update it and edit it before it can be published. So yeah, the title is To Understand Programming, basically. I even got some awards for it, like the best IT book in 2016 or something like that. So yeah, I'm pretty happy about it. It took me a while to write. It's like 600 pages as well. Anyway, so that's that. Then, as I mentioned, HonoraryBot did the streams. You can find a summary post on my blog as well, and there are links to all the 4 videos that he did. And do check the description of the videos, because I tried during when HonoraryBot was streaming, I tried to collect each and every link, well, most of the links at least, which he used, and put them in the description so you can check them out. And he did link to some amazing stuff, so yeah, I would check it out. Now, you might have seen, well, on my channel, I guess, that I did create something like a summer game dev challenge, like basically a competition where participants were given a month to code a game, but I actually told you use these assets and these assets only as a matter of constraining the approach to it. And this is already over, but the submission deadline was 3 days ago, I believe. And I received, I think, 9 games, pretty good games as well. I'm going to, probably this weekend, I'm going to release a playthrough video, or maybe not a full playthrough, but like a gameplay video for all of them. And then I'm going to announce the winners for each category. There are actually 2 categories. One was creating a game from scratch, using just like some basic libraries like SDL or SFML or whatever that acronym goes. And the other category was using game engines, like for example Unity or Unreal Engine. So yeah, there are some fun games well, there are actually, I think, only 1 game in the game engine category, so that will be an easy pick for a winner, I guess. I guess, yeah, once, well, as I told already people in the Polish stream, the first step to actually win a competition is actually to participate. So in this case, that will be double the true. Perfect. Now we can, perhaps I could replace the shoutouts with a short slide. That's a good suggestion. What I'm planning to do is I'm planning to actually include them in the scene which you see before the live stream, right? So, there's my logo rotating, there's some information about our IRC channel and the moderator, and I'll probably have a slide there which is rotating as well, with shoutouts to Live Overflow, to Murmus, and so on. So that was, I didn't implement it yet, but that's one of the ideas. Oh, one thing, there will be no mission today, because, yeah, I'm still catching up after getting back to Switzerland, and I didn't have time to make it, so apologies for that. I will try to make one for either tomorrow or next week. So, yeah, you will have something to solve then. What's the topic of the next stream? If you have any idea for the topic of the next stream, then do pass it on or put it in the comments to this video. I don't have an idea yet. I do have a whole list of topics which are actually maintained now by Foxtrot Charlie, who is also the person who prepared these slides, which you see for all of the missions. So I don't have a topic yet. I don't have an idea. I'm open to suggestions as well. Cool. So mission number 10 is the first mission I'm going to go into. And as I told you, I created this mission 2 months ago. I don't seriously don't remember it. So let's just read through it. Usually, I guess today will be also like a tutorial to how to approach my missions, how to solve them if you've never done it. I guess the idea is it should be fun, and both fun and educational to solve them. Usually we can blame our agents for weird security fails, sadly not this time. This time we shoulder the blame. We forgot the password to our secret message server, therefore we kindly ask you to both get the secret message waiting for us on the server and recover our original shared secret if that is possible at all. And the source code is here, and there is the address of the server. And I guess, yeah, this PS, the second postscriptum at the bottom of the text is that the difficulty varies on whether you are looking for the secret number 2 or secret number 1. Both are considered to be flags in this exercise. So yeah, let's start by actually going to this link, I guess. I'm going to open myself some notes so I can transcribe the links, because this is actually a screenshot. By the way, there are links to these presentations in the description under this live stream already, so if you're curious, you can check them out. Okay, here's the source code. The source code is Python, probably, which Python is it? It's Python 2, because print doesn't have brackets. If print would have brackets, then it would be Python 3. Oh, I now recall what I forgot to do. I forgot to actually change the font settings on my Vim, but I will change it in a second. I downloaded it and I'm going to rename it to .py. Sorry, the extension. I'm going to change the extension to .py. Extension, yeah. Speaking is hard. Let me change the fonts really quickly. So this is my Vim config. You can download it, by the way, on my GitHub. I do need a script which I can actually run, and it like resets all my fonts and all the settings to be higher, but I never got to it. Okay, so this is the code. I'm going to jump into it soon. What I'm going to do now is I'm going to actually check if this is still online, and or if I should actually do something about it. Okay, so this is, I guess, the second thing. I need to change the font size. No. Okay, here we go. Apologies for the delay. Oh, by the way, I forgot to mention, I did get myself a book. A book is about... Oh, you cannot see it because it's inverted, so I'm going to read the title for you. PCI Express System Architecture. And I actually also got... somebody recommended it to me on one of the last streams, actually. And I also got a book for PCI, you know, not PCI Express, but PCI, about SATA 2 and about USB, and like another book about PCI Express as well. So I decided I need to do some reading on like how does the hardware aspects of a PC's work, just for fun. Okay, so we're here now. I was going to connect to this server using netcat for starters. As usual, I do like to add -v, which is verbose, which tells me whether it connected. It did. Enter shared secret mask you want to try, and that's it. So I wanted to check what's the interaction, what happens when I connect, because it might tell me already something, or what to expect at least. I guess this is the string. So now I need to analyze it, and there is like 120 lines of code, which isn't that bad. And I guess it starts here. So I already know that both the secrets are read from the environment, so they are not in the source code, which is to be expected. I guess this is like not difficulty 1 of 10, it's difficulty 6 or 7 of 10. Then we know that the length of a secret 1 is actually 64 bytes. And we know that both need to be provided, and if they are not provided, then it just exits, so we are sure that these two strings are actually provided. And now, okay, then password is actually derived using string to binary from secret1, and then it creates a socket, a socket, right, which is bound to any IPv4 address and to this port, and it listens and it expects quite a lot of connections, I guess. This number here is actually tells you how many concurrent connections which are not yet accepted are to be basically put in a queue in the kernel. If this is like 1, then it means if one connection is waiting for acceptance and another comes, then one of them is going to be discarded. And like 10 is a rather safe value, especially that the accepts are going to be rather fast here. Then if it's accepted, actually, it creates a new thread, and the new thread is getting the socket, which is this argument passed to it. The thread is also set like a demo, but that doesn't matter, and it actually starts. So let's see what does the thread do. Now the thread is implemented, the target is set to handler. Actually, in Python you can use threads in two ways. You can either create a new class which is inheriting over the thread class, and then you create a run method, or you can just use this. You can construct a new thread object with setting the target to a function of your desire, and then the function is going to be used as the main function of the thread. So looking at this, we go to handler, and the handler actually does set the timeout. We did already observe that the timeout is rather short, right? So 5 seconds. And it calls the worker, which is here, and then when it exits, when the function returns, it actually calls a shutdown and close, which is the proper way to terminate a TCP connection. The first one tells I'm not going to neither read from the socket or send through the socket, and the second one closes. You can actually tell it to shut down, for example, reading, but you can still write to the socket then, or you can do it the other way around. It's sometimes useful to trigger some behaviors on the other side, for example, trigger a receive returning an error, but still being able to receive some data which is coming from them. It's useful on some CTFs to only like shut down half of the connections. But here's like a full normal proper shutdown. So what does the handler worker do? It first, well, we did see this, right? And then it receives until I'm going to take this function on the face value, mostly because I did write this function, so I know what it does. And it waits for the new line, and it actually receives all the data until new line is hit. And it's returned in here. The status is actually either okay or like not okay due to timeout or due to disconnected or due to some other error. So yeah, if status is not okay, then it just returns. And so some mask has to be given, and then it's stripped, and then the length is checked against the length of the password. So we know that the password is up to, sorry, where is it? Here. The password is derived from secret1, so it's at least 64 bytes there. What's string to binary, by the way? String to binary is actually, it creates a series of zeros and ones. Yeah, so it basically translates the whatever string is like ASDF. Oh, I can type here, right? ASDF into a series of like zeros and ones with 8, as you can see here. How do I escape this here? With 8 bits per byte, which is the normal usual way to do it. Now, so knowing this, we know that it's going to be how many bits? 64 times 8, 512. Yes, 512. So yeah, we know that the mask is 512, and then it checks if the mask which we provide has to be actually binary as well, so it has to be a series of zeros and ones. And what's going on here? Then it creates a byte array based on this is okay. This is a nasty hack I did. It basically just, I guess, well, it could be a much nastier hack, but that's okay. It just converts it to like the series of zeros and ones as a string to integers, like well, bytes actually with values 0 or value 1. So that's okay. Then it checks whether it actually like checks how many, the so-called pop count, population count, how many bits are actually set in this mask. We'll set as an equal to 1. And if it's less than 64, then it says no, like more than 64 is welcomed. Then it, one thing I should probably point out already here is that due to this check, and that the message here is quite unique, we can actually figure out what's the length of the password just by sending like more and more bits into the mask, into the server. So going further, then after the mask we actually send the bits, and it receives and some bits, strips them. It's basically the same as was above. It has to be, the number of received bits has to be the same as the bits which are set. So yeah, I guess we are only sending the bits for the set bits in the mask. This is going to be clearer when we get to it. It also checks if it's like this, and it also does the same stuff here, and then it checks if the bit is set in the mask, then it grabs a bit from the received bits, like just from the front, just the, you know, consequent bits, basically. And it checks if the received bit is equal to the bit of the password. And it checks how many faults are there, and if there is any fault, so if the fault is not equal to 0, it's initialized to 0 here, by the way, then it says access denied, have a lovely day. Otherwise, access granted, and we get, I guess, we get one secret message. Yeah. So there are a couple of things here to note. Well, first, which I already mentioned, is that we have to get the length of the password first to know how long the mask should be. And then we know that we have to set at least 64 bits. So I guess since the password is at least 64 bytes, that means we need to set at least 1 bit per byte, which is okay. Then we have to, for each bit which is set, right, we have basically, where is it? Yeah. So for example, if we set, like, if we send this mask, for example, 1, 0, 1, 1, so for each of the ones, we actually need to provide the bit itself to, because it's some kind of a like shared secret authentication where one side, both sides seem to know the secret, which is the password in this case, right? And one side has to prove to the other side that it actually does know the secret. So what the side, the authenticating side does, it actually says, I'm going to send you at least 64 bits of the whole 512-bit password, and I'm going to send you this bit. I'm not going to send you this bit because I'm sending 0 here. I'm going to send you this bit and this bit of the password as well. And these bits are, for example, like 1, 0, and 1, where this is the bit in this position, bit in this position, and bit in this position. And then the second side takes the password, and actually, for example, the password is like 1001, and it authenticates it, checking if the first like bit set here on the mask is equal to this one, and it's really equal to 1, so this is correct. Then it checks the mask bit 0, and this one is like skippable, so this bit here is not checked at all, and this bit is again checked, right? So this bit is checked, and it's 0, so that's correct, and the same goes here, like the next one bit is checked as well, and 1 is equal to 1, therefore it might, in this case, authenticate because the first side has proven that it knows the sufficient amount of bits of the password. Now, there are a couple of problems here. Usually in the shared secret scenario, you just don't send the bits of the password over the network. The whole idea here is to not have to send the password. And so this is obviously broken from the design point of view. Now what's even more broken is that let's look where does the password come from, right? Because it is compared with the password, and the password comes from here, like string to binary, from secret1. But secret1 actually comes from the environment, and environment variables usually have ASCII characters, so they don't have any binary characters, which means that if we start converting whatever the password is into binary, then we get 0 unknown bits, like 7 unknown bits, then 0, 7 unknown bits again. Why that? Because, well, all the ASCII characters actually have the topmost bits set to 0, because the printable ASCII characters are in the range of 32 to 126. Before that there were the control characters, and after that there's also another controlled character, and above that from 128 there's the extended ASCII, which is rarely used in the environment variables, I would argue. So my guess is, and this is a guess, an educated guess though, that the password is going to be ASCII only, like printable ASCII only, and therefore we already know the topmost bits, and we also know that since the password has to be 64 letters and we have to know 64 bits, then we basically know them already. They are going to be zeros, all zeros on the top bit position in each byte is actually zero. So we can authenticate even without knowing the password, assuming that whoever configured this server didn't do anything crazy like just putting, you know, non-ASCII stuff in the environment variables, which is by the way technically doable with the exception of a 0 character. So let's try to implement it after drowning myself in tea, I guess. Cool. Are there any questions? No. If you have any questions or comments which should get to me, do write the nickname of this guy next to your question, so he actually notices and passes it to me. Okay, I'm going to find my favorite framework for this, which is my Pwn-based script, which is like somewhere on my GitHub as well. I'm using it all the time, and it doesn't do anything magic. It just like creates a network connection, and that's about it actually. Yeah, seriously, I'm drowning myself in tea. Okay, so I do remember having the address be somewhere here. I'm going to copy paste the address where we connect to. Okay. And now I need to, after connecting, I need to send the mask. So the mask is going to be, well, this is going to be really easy, right? Send all, and it's going to be a pattern like this. 1, because on the topmost bit, I guess, sorry, one more thing I need to check is actually like, is the topmost bit actually on the left side or the right side? Because that isn't obvious. And no, it's actually, so bit has to be 7 to get to the topmost bit, and it's going to be written to 7, so it's actually on the right side. So yeah, if we have a value of like, I don't know, like just 128, then it's actually going to be 0000001. So that's one of, you know, there are 2 ways basically to write them, either like most significant bit to least significant bit, which is the most intuitive to us, or the other way around. Both work, why not? So 1, 2, 3, 4, 5, 6, 7. Is this 7? Vim confirms that it's 7, and we don't know the length of the password though, and this is somewhat problematic. I'm just going to use a variable for it. So the variable is going to be called I as soon as I find it on the keyboard, and to this I'm going to add concatenate actually end of line, because why not? And then I need to send the same amount basically of zeros, because I know that the topmost bit is going to be 0. My apologies. So we do it like this. Okay. And yeah, and then we just jump into an interactive telnet session, which will print out everything else which is going to be sent, which is fine. But we don't know what is the size of a password. We know that it's at least 64 letters. We don't know if it's more than 64 letters, so I'm going to do like this. For I in range of 64 to 128, yeah, do this. And that's about it, I guess, and now I can just run it. Python pawn base. Can you see the console? Yes, you can. Mask to short, okay, and I need to... No, okay, this isn't working. What should I... How do I... Connection was aborted, that's okay. I'm fully okay with the connection being aborted. I guess I have to do that. Yeah. So, yeah, anything, whatever, doesn't matter. Yeah. Okay. Too short. Oh, wait, I'm making a mistake of actually not writing how many bytes I'm trying. This many bytes. Okay, perfect. No, too short. Yeah, perfect, got it. Here we are. So it's 70 characters or 70 letters, and well, obviously we got the bits right, so we got the access granted, because again, top level bits of of printable characters are always 0. And so we know them without doing like anything more. Then yeah, just another secret message is the flag we were looking for. So this is the secret 2, this is the easier secret, which was we were supposed to recover. So that's one thing to do, and now the other thing to do is actually to recover what is the correct mask. And that's somewhat easy to do as well, because what you do is, what you can do, I'm going to, I guess, uncomment it because I'm going to change the way. Oh, you know what, I'm going to make a copy of this so I can put it on GitHub later on. Okay. Now, what we can do is now basically try bit by bit with, using this mask, we can actually take a bit which we don't know and set it to 1. And then we can just brute force it because there are only 2 options, right? It's a bit. It can be either a 0 or a 1. And using this method, we can actually try each and every bit. So in the end, we basically get everything, right? Cool. So how do we... what's the best way to do it? Okay, I'm going to remove this because this will be probably no longer needed. I will be looking for access granted though, so receive until and access granted. And let's see what it does now. This is quite... Yeah, okay, it works now. It returns false if, like, it failed, so... yeah, so that's fine. So I need to change my approach on how I create the mask and how I create the... well, the bit array, or the bit pattern I'm actually sending. I'm going to do, I guess, a byte array of, like, mask is going to be a byte array of, we already know it's 70 characters, right? So 70 times 8, this is going to be the size, and it's going to be all zeros, which is fine by me. Apart from that, I also need to create a pattern, where the pattern is going to be also another byte array, I guess. But apart from that, I guess I need to convert them to strings, which is, yeah, I can write just a function for it. I'm thinking if I can do it in a, like a smart, fast way, I guess, yes. Okay, so it converts the byte array into a string. And, but in case of, we'll use it in case of a mask. And now to create the mask, I'm going to use this I here as actually the bit which I'm going to check. So, okay, well, I guess I have to use a different name, but range 70 times 8. Then in the mask, if the mask is equal to the top bit. Now let's start with the easy case. If, sorry, not the mask, if j is equal to I, which is the bit we are testing. I know that the name choosing here isn't the best, but let me change it to test bit. Yeah, this is way better now. And now I can use I here. Perfect. Then I do set, like in the mask, I do set the bit. And the pattern is something I guess I should actually pass here. So pattern, and I'm going to create it here. Yeah, because the pattern is something which is I'm going to put something there a lot of times, and I'm going to fill it while doing stuff. So this is fine. Now, if no mask from yeah, just one, I guess that's it. And now if test bit, no, I divided by 8 is equals to 7, so we are actually on the topmost bit, then we also need to set the mask to I, which is 1, and to continue, and this is fine. Now I'm going to assume that the pattern is actually going to be correctly sent, but there's one more thing I need to do. I need to actually create the pattern which I send there, because I don't send all the bits of the bit pattern. I send only the bits which are actually pointed to by the mask, right? So I need to do something like this. If the mask is set for this bit, then O, I'm going to append to O either 0 or 1, depending on the pattern itself at this position. Yeah, which is a pretty nasty hack. I like it. And now I can send first of all the mask, which is send all, convert the mask, and add a new line, obviously, which I always forget during CTFs. And the other one which I sent is just the O. And now it can either fail, so if it's false, then if ret is false, then I just return false. I do need to close the connection. So let's close the connection above. Let's close it here. On the other hand, return true, because we actually did find the correct bit on this position. Okay, so this is fine. Now I'm going to do one more thing, which is because what I do here is I run it for each and every position of from 0 to 512. It's also going to run it for the, the known positions in the pattern, but that's fine. For the zeros in the topmost bit, but I don't care about it. So if it actually returns true, that means that there is a 0 in this place on the pattern, right? Because I'm not changing anything in a pattern. There are always zeros there. So if we call it and everything is fine, that means that there was a 0 there. But if something is not fine, so we don't get the access granted here, if we don't get it, if it returns false, so it actually, red will be the string with this text otherwise. But if we don't get there, that means that it's actually a 1. So we need to change it in the pattern to 1, and we don't need to retry it. We are sure that there is a 1 because it's not a 0, right? And I guess you can put something like this so we know that it's actually working, and in the end we can print it out in somewhat decent way. How do you print it out in a decent way? So the pattern is going to be, I guess you convert it to zeros and ones, but now it's kind of reversed. So you reverse it, and then you convert it into an integer, and then you convert that integer. Do I need to convert it to an integer? Yeah, I guess it would be best to convert it to an integer. And now you need to actually do byte split on this integer, which I guess I can do encode hex. There's probably a better way to do it. And now I can... No, not encode hex. How do you... in Python... whatever. Let's start with this. Yeah, and let's just do something like this. OCHRX. We just grab the lowest byte and then we just right shift it by 8 bits, which should be fine. And now we print, but it will be, this one actually, like, due to this, it will be backward, forward, I think. So we can print both this and reversed. And this should be fine. This should probably even work. Let's see how many mistakes I made. 2 arguments we should give to go, which is correct. We also need to provide the pattern. Okay, and it's working, and it needs, I guess, to go 512 times to actually print it. Yeah, so if there are any questions, I guess we have about 1 minute or maybe 2 minutes. I guess I can also start looking for bugs because I'm pretty sure I messed up something. Maybe not here, this is probably okay. I'm not sure about this conversion. It's ugly. You usually don't do it like this, but yeah, whatever works, right? By the way, one thing I didn't mention is that I'm going to probably make more videos, like not live streams, but videos on my channel. Not a lot of them, but maybe 1 or 2 during a month. That would be good. Any good Python books apart from Automating the Boring Stuff and Black Gray Hat you can recommend? Actually, no, I didn't read any Python books, so no idea. Okay, here we go. This crypto is absolutely secure and there will be no problem with it, I guess. That's my guess. This crypto is absolutely... Yeah, maybe... Yeah, I don't know. Maybe that's the whole flag, actually. Let's see how many characters is this. This is... what? Oh, here it is. 64 characters. So, why is it 64 characters and not 70 characters? Oh, because I messed this up. Yeah, it should be 70. But, well, I guess the thing here is to change this to 70 times 8, right? And just rerun it. I'm not going to do it now. Why don't I use \r keeps my terminal cleaner? I would normally sometimes use it, but for CTFs, I just don't care. So, that's your answer. I mean, yeah, if this would be like a real application I'm writing, and the idea is to keep the terminal clean, that's a good way to do it, but not in this case. So I'm not going to run it. I guess this is the second flag, and this is also the solution, the full solution to the first mission which I wanted to present today, and I think also the most difficult one as well. So let's go through the presentation. Furthermore, like, sorry, let's look who actually solved it. And yes, this was the live demo. There's a blog post from Hastur. And all of these things are clickable. Foxtrot Charlie is actually making them clickable, so don't worry about it. You can just click, you don't have to actually retype everything which is written here. And we do have a full write-up here, so that's actually great. If you didn't get something from my explanation, which might have been a little chaotic, then just look up on Hastur's write-up and look at his code, look how he approached it. There are usually, you know, a lot of ways to do one thing, and it's good to pick up tricks from other people. Next write-up is actually from Adrian Laskowski, which, yeah, also is a full write-up with explanation of everything. So again, if you didn't get something I explained, do look up on these write-ups. Some more people did solve it. Marek Zori, for example, 2767 Mr. or MR. Also both secrets. Then Jofra, who also solved it, so congratulations. And from Norbert, there is a link, and the link goes to Solver, and we also see like 2 parts here, so I'm assuming, I'm assuming that the person did solve it as well. So congratulations, and thank you for sharing your code, and also thank you for making write-ups. Andrew was the first person who actually solved it. The yellow or gold border around it tells you that. And yeah, congratulations. Well done, well done. I accidentally inverted the bits. That's an easy mistake to make, actually. So yeah. And Jarek has sorry for DDoSing my server. Yeah, don't worry. My server is already used to being DDoSed by people who are solving missions. So, yeah, I think it went to like the peak was 600 queries per second, requests to the server per second, and it's still, my blog was still loading, so that's fine. Jarek is in the red border because it's a partial solution. Partial solutions are cool as well, so thank you for sharing. And mission 15 is coming soon. It's not coming today, it's coming soon. And thank you for, again, to Foxtrot Charlie for actually making the slides. And I guess that sums up this mission, so we can go to the next mission, which there will be some like super easy missions as well. So I guess this might be 6 of 10. It might be not easy as well, but let's go through it. Finally, some real work. One of our field agents managed to infiltrate suspects' hideout and steal a pendrive, possibly containing important information. However, the pendrive actually requires one to authenticate themselves before accessing the stored files. We gave the pendrive to our laboratory and they managed to dump the firmware. We looked at the dead listing they sent, and for our best knowledge, it's some form of Elvish. We can't read it. Here is the firmware, and there's a link, and off you go, bring us back the password. Yeah. Work. Okay. Where are all the missions stored? They are actually at the end of the videos, which you can find on my channel. And as soon as we get the website running, which will probably happen this year, I hope so, then you will also get like actually a nice listing of them. I know that I think some people have them on their GitHub or something, but I didn't put them on GitHub for some reason. Yeah, I might put them on GitHub. So yeah, that's actually a good idea. Okay, but let's look at this form of Elvish. What form of Elvish is this? And this form of Elvish is actually Python. This is the, so it's not just Python, it's CPython. CPython, which is the, you know, the default implementation of Python. If like somebody uses Python and doesn't say something weird like I'm using Gyphon or I'm using Iron Python, then they're probably using CPython. Now CPython actually, it's quite a lot of people are under the impression that it's an interpreted language, which isn't fully correct, because Python is actually a compiled language, and you do compile Python to this sort of bytecode, which is it's rather easy. And where's my mouse pointer? Here we are. Yeah, it's rather easy, and as you can see, the names are way more meaningful than the standard I can change colors. What did I press? How did I change the color? I didn't know it can change color. Anyway, the names are more meaningful. Okay, I need to change the color. Oh. Okay, so I guess there is like R is for red and Y is for yellow. I guess B is for blue. Perfect. I just learned a new feature. Anyway, the names are more meaningful than x86 assembly, which is like blah, blah, blah. And you're like, what? And you have to look it up in the manual. Here you can actually, you don't even have to look up in the manual. You just read it and probably can guess what it does. Apart, there are some exceptions though. The bytecode changes from basically major and like minor Python versions. So like if you know the opcodes in 2.7, then the opcodes in 2.6 are basically similar but not the same. And similar in like the opcodes of Python 3.1 are a little different than Python 2.7 and 3.2 and so on. But they're rather easy in the end. So you can just basically read it. So I guess apart from the opcodes, we also have this. And if you did a little digging into Python, especially Python, I guess 2, then you know that when you create a function, Python actually compiles it to a function object, and that function object has something called a code object, and that code object has a lot of fields like this. This is like CO from code. And these fields basically tell you all about the function, but which is like metadata. It's not really related to the bytecode itself, but it's there. And it's especially like this tuples here are heavily used in this, like these arguments. Most of these arguments are actually references to one or the other tuple, which is here, or like the third tuple. So what do we have here? We know that the function takes one argument, and we know that it has a couple of constant values, and like these are the constants. There's none, there is this string, another string, and this for more variables. And there's also the flags. We can ignore them safely. We know the name of the function. The name of the function is check password, and we know the names. The names are actually basically like global names which are being referred from this function. So like usually global functions or global variables. And we have decode, len. It can be like, it doesn't have to be a function. It can be a method for an object as well. We have false, which is funny a little, I guess. It's funny because of the quotes. Is it a string? String false or something? That's weird. Then we have all, zip, and or, like, apart from false, all the basic functions, right? Then we have the number of locals. Now, if I remember correctly, the number of locals might or might not, I don't think it includes the argument count, but there's like something like a stack size, which does include the argument count, and it's here for some reason. It's a little more complicated. Actually, if you're Polish and you look into the second book I co-authored, there is my chapter about reverse engineering Python there. So yeah, variable names, which are local variable names, C, good, CS, and CGU, whatever. This means, well, I guess good is like some kind of a flag, which can be false, I guess. And then we have the code. So I guess we should reverse engineer the code. And I'm wondering if I should do it. We have about half an hour left over. So question, actually. Do you need any help with the website from the community? Thank you for asking. I really appreciate it. I don't know yet. Maybe. So currently we have like, I think 6 people in which are like helping me with the live streams, like KrzaQ, for example, Masakra, and Disconnected, which are also the moderators. Then Foxtrot Charlie, who is helping with scheduling the stream, with presentations. We have Vesim and Maryush, and if I missed somebody, I'm really sorry. So for now, we have a lot of unused manpower. That being said, I might ask the community for some help at some point. So thank you for asking. I really appreciate it. To get back to this, yeah, let's reverse it. I mean, it's short. Let's do it. Oops. So usually the way I reverse engineer stuff like that is I just copy paste it to Vim, and I try to translate it to a high-level language. For example, we have, what we can do here is we can basically, if there's an opcode like load const, then the const, this is actually an index in this, well, tuple, right? So we know that when it load const, it actually does loading of this. Then it's a load attribute, which is, I guess it also, it takes from the name, so that would be decode. And then there's a second const, which is hex, which is this. And then there is a call to a function. So basically what we know is we know that on the stack, Python is a stack machine. I mean, most of the like Java, Flash, and so on, and Python and PHP are stack machines. So they're like, put stuff on the stack and then like pop them from the stack, for example, while running the functions. Is, if you know x86, like trivial concept, basically. Okay. So, well, we know basically what's happening here, right? This is taken and its decode is called with an argument hex, because from the, this is put on the stack, and then from this we load the first argument, which is decode, and then we put on the stack, this is put also on the stack, and then we put on the stack this, which is hex, and then we call it which with one argument. So the hex is actually the argument and decode is actually what's being called, which is supposed to be a kind of like a function object or a bound function object or a method or whatever. So yeah, so we know that this is happening. Now the question is, what's happening with it? So the result of this function is going to be put on the back on the stack, right? And then store fast is actually like grab something from the stack and put it in a variable, and variable will be variable number 1, which is good, I guess. So good is the name of a variable. So we can, I guess we can move it a little further down and do something like this. Good equals 2. Perfect. So we have the first line. We don't know actually how many lines are there. Usually there's like a like, I don't remember, like line count. I'm probably making up the name, but there's something similar which does tell you about the number of lines in the function. So yeah, but we don't know, we don't care either. Then we have another, as you can see, I'm basically like separating it by function call. So it loads the first global, which is globals are the names, so that would be len. Load fast. Load fast is the is from the variable. Sorry, is it going to be? Oh, it's going to be s. The s is actually the argument. Yeah, now I remember what I was thinking about. This does include the argument, and this also includes the arguments, and knowing that arg count is 1 actually tells you that s is actually the first argument of a function. So you know that there is like def check password here, which takes s as an argument. And here we know that we're calling the len of the first argument of the function. So we're basically checking, I guess, if the password is correct, or like the correct length. And then we are again calling len, and the len is of the first of good, actually. 1 is good, right? Like you can see here in the variable names, so it's like this. And then we are comparing them. So the code is probably something like if len s doesn't equal to len good, we jump to this line. Sorry, if this is false. So this is a double negation actually, right? Because we are comparing if it's not equal, and if it's like the result of it is actually false, which means if it's equal, then we jump into 43, so we jump here, right? If it wasn't equal, so if the result of the comparison was true, then we actually execute these two things, and it loads global number 2 and it returns. So we definitely don't want to go here. So it's like if it's not equal, then return. And what do we return? We return global variable number 2, which is no, that's not global. Sorry, this is global's false. Oh, I know. This is a string because it's actually the key in the dictionary of the global variables. So let me run Python for a brief second. Yeah, if you run Python, then there is even a function called globals, which and built-ins as well. So built-ins. No, there's not a function for it, but that doesn't matter. How did you list built-ins? I never remember it. Is it just... No, I think it's just like this. And you do there of it. Yeah. And yeah, and because this is basically like a dictionary kind of thing, then false is somewhere, probably somewhere here. Or it's like, it just doesn't show. But it's important thing is a key in the dictionary. So yeah, it returns false. And under that key, obviously the value is actually the object false, right? So knowing this, we basically reversed until here. Okay, now I'm going to do this though. Yeah, because I need to see this. I pressed Ctrl W V if somebody is curious. And there is a question. Yes, there is a question. Perfect. Is this code compilable? That's a very good question. I don't know of a Python assembler. There probably is one. It might be compilable after changing some stuff, but it's also short enough to actually you know, reverse engineer it. Okay, Mormos says that I can just do dir dunder built-ins. Dunder. If you're wondering what's a dunder, it's the double underscore according to the Python documentation. Dunder or dunder. Sounds like something from the Lord of the Rings, I would say. Okay, so a global variable number 3, which is 1, 2, 3. Counting from 0, obviously, that's all. Build list, which is, I guess this, var number 6 zip. This is going to be fun to actually reverse engineer. Then load fast, that's the s, which is the argument, and good. And we call the function with 2 arguments. So we call the zip function with 2 arguments, which is s and good. And we create a for loop basically. So it's going to be a for loop of some things, which I don't know yet, and these two. Apologies, and I don't know yet what this all is about, actually. What does this do? But I might find out soon enough, so I'm not going to skip too far. Okay, then it unpacks the sequence. So it gets 2 things, right? It gets a character or a byte from the first one, from the argument, and it gets from this decoded string. Now, it unpacks it and puts it on the stack again, and it puts them into 2 variables, which are CS and, yeah, which makes sense, right? CS and CG, where CS is actually for the string, which is incoming, and G is for good. So I know this is happening. Now I load global 5. Okay, global 5, 0, 1, 2, 3, 4, 5, which is ORed. And I load the second. This one is 1, 2, yeah, so CS, so that's going to be ORed of CS. And I call it, perfect, so I have a piece of a line probably here. And then I load const 3. Okay, perfect, constant 0, 1, 2, 3, 89. And I do subtraction of it, so minus 89. That's the binary subtract. It's binary as in having 2 arguments, that kind of binary. Then I do load the constant number 4, so that's 1, 2, you know what, 0, 1, 2, 3, 4, 5, 6. Yeah, I should have done it at the beginning. I usually do it. And so I do have to take it into brackets. And then I need to end it with 255, which makes a lot of sense, right? Because I just did a subtraction and it could give me a result like -3 or something, or my apologies, -3 or something. So that probably we want to take just, you know, just the unsigned byte of the value. Yeah. I actually did order the stand for the microphone, so you will not hear the keyboard so much and this piece running away so much on my next streams. Maybe not tomorrow yet, because it didn't arrive yet. Perfect. Now I do an XOR, or an exclusive OR with 5, which is 115. And I do another XOR, right? Yeah, I do another XOR, which doesn't make too much sense, but okay. That's what the code says. So I do this, and then I load a global, which is 5. Sorry, 0, 1, 2, 3, 4. Okay, and 3 is CG. So I just do ort CG, and I call function number 1. Wait, no, I call a function with 1 argument. Oh yeah, right. So this is, sorry, it should be like this. This is correct now. And then I compare them. So yeah, it's like this. So now I basically have the cryptographic method of how it's actually, you know, encoded, the good variable. And I guess I don't even have to read the rest of the code. I can just basically reverse engineer it. So, or actually write a solver. A solver not as a Z3 solver, or like an SMT solver, just like the code which is actually solving it. So I'm going to need this. And I need to take this formula. And this code, this is actually reversible, right? So I can just reverse it. When reversing the code, you actually need to start from the back, which means I need to. So after doing all this, I'm going to get CG, right? So CG XORed with these two values. Are the values correct? Yes, they are correct. And then we add 89, and then we take 250, like do the end. It might not, like the end might, you know, might seem like it should be done here, but here it doesn't change anything because I know that CG is like a byte, a correct byte, and I do need to, so I just removed it. It should be here, but I just removed it, but I do know that it should be somewhere here, so I did put it here. Okay, so for CG and good needs to be decoded, obviously. Decode hex. Do this, and actually print it as a character, but, well, no, like do like this. Like concatenate it with, sorry, yeah. Okay, perfect, got it. I think I got it, at least. Let's try to execute it. Solver. Blah, blah, blah. Ort. I forgot changing CG from a string to actually, yeah. And this is the correct flag. Ha, that actually worked. So yeah, that's it, basically. All this code basically came to, as you can see, like one line here, second line here, third line and fourth here, and like another line here, one more here, and probably one more, so like 6 lines or something. So that's it. Now, I actually did give another task here, which is like bonus points for recreating the original high-level code, as in having the code as close to the original as possible. So I'm going to now look on my somewhere on in my directories I do have the code, the original code for it, so I can take a look how was my code close, but that doesn't matter. What matters is, was your code close? I'm going to look through the solutions in a second. Which mission is it? It's mission number 11. Today I think I'm going to do like a couple of more easy missions, like the trivial missions, but I'm not going to finish all of them, so I'm just going to skim through the solutions of the last one or last two. Okay, is this it? Yes, this is it. And this is the check password function. So I had this line correct, I had this correct, no, this wasn't, I didn't have this correct, this wasn't correct at all. I did assume that 4 is somewhere else, I didn't know what all is all about, pardon the pun. Let's see how you did then, maybe you did better than I did. Let's start with Chris. Chris actually made a huge write-up about it. And so thank you for making write-ups, I really appreciate it, especially that, as I always repeat, it's great for beginner people who don't really get everything which is going on during my streams. I know that some streams are sometimes complicated, so they can just, read in their own time everything that I'm making sound really chaotic and like taken out of thin air. In your write-ups, it's usually there, so thank you for writing them. I really appreciate it. Yeah, so this is well reversed, and then we get here, perfect. I think that's actually apart from brackets, where brackets are not, yeah, that's it. Well done, Chris. That's probably the perfect reverse engineered code. And what was Paint about? Yeah, so something I did a couple of years ago for April Fools was actually publishing a Python tutorial where I was first programming in binary code in Python, and then I actually jumped into, and then I actually jumped into creating modules in Python using MS Paint. And it seems that Chris liked it, so there is some fun stuff about creating a solution in Paint, I see. So well done, this is actually amazing. And check out Chris's post, it's really worth it, it seems. I'm going to give you links. Oh, and well, Chris used decimal numbers instead of hex numbers, which he says on chat. That doesn't matter at all. I mean, it's after compiling it, there is no difference. Similarly, for example, you used single quote here, where I did use double quotes, so that doesn't matter, that's not reversible. Same with comments. So I still consider it like a perfect reversed code. Okay, so that's Chris's. I think there are 2 questions I need to remove. One from Marmars, which I did already mention, and another is from Foxtrot Charlie. The link of the image write-up leads to write-up. The link of the image comments leads to the comment. Yes, I know, I just misclicked. So, yeah, but that's true what Foxtrot said. If you click this, it goes to the comment. If you click this, it actually goes to the write-up. Next, Paweł. Paweł did also write a write-up. So, let's see his code. His code, no, this is the reversed engineer one. It's, I guess, well, as you can see, it's not close to the original, but doesn't matter, obviously, because it's a matter of, like compressing these ones, and he also went for the solution I did, so for a separate for loop and separate this. That's still a correctly reversed code, right? It's not identical to the original. That being said, that doesn't matter. It's just like a random idea for bonus points. For no bonus points, by the way, for bonus points, which I did. So yeah, well done. Thank you for creating a write-up, and well done. Norbert was actually the first person who did solve it, and he also shared his code. So thank you. Then Stefan also has the correct flag, and so does Marek. Well done. Also, Gurali did it. I guess did it. I'm going to check. I'm going to check you. Yes, this looks correct, so I guess that's correct. I'll use the code. Neo Overflow also solved it correctly. Well done, and so did Jeremy V or Jeremy 5. I don't know. And again, the mission will be later on. These slides were made by Foxtrot Charlie. Thank you for doing them. And I will put the code, this reverse code, and I guess also the notes on GitHub later on. So let's get to the next mission, which is 2 out of 10, which should be really easy and really fast as well. So sorry, where are my notes? I did close my notes. That's not good at all. And this is one I'm actually going to skip. I'm going to tell you how to solve it, but I'm not going to decode it because you do it basically pen and paper. You don't need a computer for it at all. So let's read it. Our agents managed to install a hardware keylogger in the suspect's computer. After they retrieved it and dumped the recorded data, here is what showed up, and we have something. Help us decode it and to know what was basically typed. Now, if we look at it, then what you can notice is that this is not printable ASCII, neither is this, and this isn't either, and neither is this, and this isn't either, and so on and so on. So what is it? Now the important part here is that it's actually a hardware keylogger. Now if you have a keyboard, and you probably do have a keyboard, then unless you're, I guess, on the touch screen watching this on a device with a touch screen, never mind. If you have a keyboard, then it doesn't send ASCII codes or Unicode codes into your operating system. What it does send the key codes. So basically it tells the operating system which key on the keyboard was pressed. And well, you can have quite a lot of different keys, but for example, if you have the A key, that doesn't mean capital A, that doesn't mean lowercase a, it means just that the A key was pressed. And whether that means like, was it capital A or like lowercase a, or maybe some shortcut with Control and Shift being pressed at the same time, that's up to the operating system to decide. And all the keys are basically treated the same way as well, what was pushed and what wasn't pushed. Therefore, it makes sense for the keys to actually have different codes than than the, you know, the ASCII or Unicode codes are. Therefore, these are not ASCII. This is basically one of the keyboard protocols. I think there are 3 of them. So if we go to osdev.net, I believe, was it? Yeah, and if we look for keyboard here, we get sets of scan codes. This is basically the protocol for the keyboard. And yeah, this is basically what you have to use to decode it. And it's there's basically like a code, like a scan code for a key being pressed or for the key being released, where if we go down, then we get the keys which are released. So if we start decoding this, let me copy paste, for example, this part. Then we have what? We have 58. Let me do it maybe like this. We have 58, right? So let's look up 58 here, and 58 is actually caps lock. So caps lock was pressed here. And then we have FO58. Now, FO58 is actually caps lock being released. So if we find it here, here it is. Yeah, caps lock being released. So that means that somebody pressed and released it. So, well, just pressed the caps lock, as in like you normally, you know, when you... Sorry, usually the terminology is like this. You hold the key down and then you let go, right? So pressed usually is used as down up. And this means that caps lock was turned on, basically. which isn't correct, by the way. Caps lock was toggled. I don't know how do you pronounce the word. Anyway, it was changed. Because we don't know the initial state, right? The initial state might be, maybe it was on and whoever was typing just turned it off. We don't know that, but I'm going to assume it was actually off, and whoever is typing is turned it on. And then there is 1B. What is the code 1B? The code 1B we have somewhere here. There's 1A. There's 1B. S is pressed, and we know it's actually a and then it's like depressed here, like released. So we know that this is S. Then we know that this is again the caps lock, but turned off. So we know that the following characters will be actually capital, lowercase letters. Then we have 44. 44 is O, so this is O and O being released. Then we have something and something being released, and so on and so forth. Now 2D is 2E, 2D, R. So that's SOR, and well, my take 35 is actually Y. Yep, 35Y. And so on. So sorry is the first word. I'm not going to decode like everything. Let's just jump into solutions. Let me make this bigger. But this is what you had to do. You basically had to just decode the keyboard protocol. Now, on one CTF, there was a challenge like this, and we were like staring at this, and it took us hours to basically figure out that it was the keyboard protocol, and not like some encrypted message or anything like that. Sweet. So Paweł Łukasik was the person who, I guess, first submitted a solution. And yes, this is the correct flag. Sorry, I don't speak keyboard. So, oops, I think I broke something. Thank you again for writing the solutions. And there's also a code to decode it. I actually created the challenge using pen and paper. I wanted to have like a script for it, but in the end I decided, nah, let's just like pen and paper, it will be faster. But I do see that Paweł did write some code for it, so thank you for sharing. Then we have from Artur Nowak also write-up, and also a nice set, I guess. So there are like 3 sets of the scan codes, right? I used the second set, which is the most popular, but there are 2 others, so you could try that. It becomes really fast, really obvious that whether you're using the correct one or not the correct one. And this is done actually in JavaScript, so well done, well done. Then we have NeroX652 _ is the person who solved it as the first one. So well done, congratulations. Then we have Norbert, who also solved it, and a Neo Overflow. Well done, well done. Then we have Gurali and Fenrir, which are also... Oh, it looks like Fenrir also did it with pen and paper. So, oh, you probably don't see it. Foxtrot, if you're watching this, I guess should be like... I have this nasty thing here with my face, so I guess we should put this a little higher. Yeah, or I could hide myself, I guess. Okay, so these are all the solutions, so well done. Let's quickly go through the 2 last missions. I'm going to like finish it in... Yeah, both are like high difficulties. I'm not going to go through like full solutions of them. I'm just going to briefly tell you what you had to do, if I remember it, because again, these were made like 2 months ago. One of our agents successfully hacked a suspect server, though managed only to get access to one of the other non-privileged user accounts on the system. Thankfully, it turned out that Wireshark was installed for all the users on the system. So everyone could basically sniff the traffic. So our agent turned on the sniffer and waited. For example, Wireshark executable could have cap _ sock _ raw capability, which is basically you can set a special flag to an executable, and then that executable, even though it's launched without root privileges, is not a SWIT binary, it still can get access to something that normally only a root process could do. So yeah, so this is like, I'm explaining this because when I was writing it, I was like, oh, maybe this is like too stretched, like, but no, it's actually defensible, I would say, at least. After a while, the suspect started a remote TCP debugging session using GDB. The pickup file containing the packets is here. So this is the pickup file, so we get a pickup file from a GDB remote debugging session. We think that the suspect was debugging a simple authentication service. Can you find out what is the correct password? Now, what you had to do here is first you had to do two things, but I guess you could do only one thing. The fast solution is basically to look at it and notice that there is probably enough of binary data there that you can just dump an ELF executable on the ground and put it in IDA without even thinking about the GDB protocol. Now well, not the proper way, the full way to do it, to have, like, you know, the best educational experience, is actually to understand the GDB protocol, which is surprisingly mostly a text protocol, which is rather easy apart from like a certain quirk in the run length encoding compression. It's really easy. The compression is really easy there, and the quirk is easy to figure out as well. You just have to +1 in one place, which isn't obvious from reading the documentation. It's well documented, by the way. So you could do that, and then you could basically see what was happening during the debugging session done remotely, and then from that you could just dump the parts of the code, reverse engineer them, and after reverse engineering you could actually get the password. So it was basically you had to do two steps. First is actually get the binary from the remote debugging protocol session, and second, reverse engineer it and get the password. So without a live demo, because we are running short of time, Paweł was the first one to actually solve it. And yes, there is the correct flag, which is this was for forensics task, and this pun is intended. And yep, it was. Yeah, it was. So again, Paweł, thank you for posting the solutions. I see you're like done all and every one of them. This is how the protocol looks like, by the way. The GDB protocol from like the server and the client, or the other way around. It's not hard. It's actually a simple protocol. So yeah, like just learn it. It's simple, seriously. And we have like, apologies. What was Paweł using to reverse engineer it? Probably, I think it's IDA or something. Yeah. Anyway, cool. Well done. As you can see in the end, it wasn't like a super complicated algorithm or anything like that. I guess carving out the binary was the hard part of this challenge, and then it was like, yeah, like the simple stuff. So well done, and thank you for posting solution. Then we have Gurali, who also did post a short write-up, and I guess what's written here is exactly what I just told you. Sorry, I'm not going to click it. Then M3R8 is like Marate, DMTR, like Dimitri? I don't know. I'm sorry. I'm terrible at names, as you know. And there's also noted down how to solve it. So thank you for posting that as well. Congratulations to all the people who did solve this challenge. There are, as you can see, at least 3 of them. So well done, and this is a fun challenge, especially if you would like to learn about debugging. And I actually like remote debugging protocols. They are simple, like seriously. I saw it on one CTF actually. The problem on that CTF was that it was a great task. I really loved the task. The problem was that the part with the flag was actually not in the session due to a mistake, but I chatted with the organizers later and I got a full challenge. So I managed to finish it after the CTF. It was really fun. Oh, Pavel actually says it was Realize. Realize, what is it? I think I've heard about it, but... Whoa, they have like a magical animation, so it has to be good. And it's... what? It's Hello World, new UI. This is a Windows path. Yeah, it looks full pro. I don't know. Did anyone of you folks use it, by the way? How about the WinDBG protocol? I don't know, I think Yuru actually had some research on that. Okay, I guess I need to take a look after the stream at what's Realize. Somebody, I think, sent me a link to it already. One more thing, before I forgot. There's a great book out. Black Book, Fabian Wolfenstein. Yeah, exactly this one. Game Engine Black Book from Fabian. If you're into old games and reverse engineering, like this website is a total must. And the book is just out. It's about like basically reverse engineering the Wolfenstein engine, like Wolfenstein 3D engine with all the like fun stuff which was there. And I just can't wait to get it, basically, in my hands. I already ordered it. It I think came out yesterday. Actually, thanks to Andrzej Albertini who pinged me about it. And yeah, he has a lot of write-ups, as KrzaQ points out on the chat, on his site, and they're like just awesome. So check them out. Sweet. Okay, last mission, really fast now. We sent one of our scanning mapping drones into a maze discovered under the suspect's hideout. While running a post-mapping data integrity check, the drone crashed, like literally, it hit a wall. And we lost the map, which wasn't yet stored in non-volatile memory. Our forensic experts managed to grab the log file from the post-mapping data integrity check, which luckily was transmitted over the network, and believe that it might be enough to recover the map of the maze. So we basically get a link to a source code, and we also get a link to the log file, and we're supposed to figure out like what did the drone actually map. And this is kind of a spin-off of a task I already had on my Polish live stream, where you actually could somewhat control a drone which was scanning a maze, but this drone already scanned the maze and you have a log file. So it's more of a forensics log analysis task, I would say. Now, let's see this. I'm not going to fully go through it, but I will tell you what you would have to do. The log file looked like this. Basically, the drone could move only like north, south, east, or west. And if there was a wall, the log file would say a wild wall appeared, and it wouldn't move in that direction. It says like it's trying east, but then there's a wall, right? And it would try then going north, for example, and then it try going east again. And there is like this is a long log file. And after, you have to basically create a map based on where the drone could go and where the drone couldn't go. And there's like basically like just a couple of messages which tell you that there's a wall, or that the drone was already there, and or whether the drone is stepping back to the location it already like was previously. So yeah, and after going through this log file, you can basically make a 2D map of the whole maze, and having the map and displaying it as a bitmap gives you the flag. The source code is, I guess I didn't really have to give the source code because it's quite easy to figure out from the log. What is it? So let's look at the solutions, because I'm pretty sure there are some bitmaps where Pavel obviously solved it and has written a write-up, so thank you for doing that. And yeah, this was the maze, which is correct. I guess if I make this a little smaller, it becomes pretty obvious what's written here, right? It's like 6 times 9 is equal to 42. And this is the correct flag. And above there is actually a maze, and the drone like went like blah 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 blah, flying, 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 and then finally got to this room and went all around these digits. So yeah, no, wait. So yeah, 6 times 9 equals 42. That's the correct flag. And thank you, Pavel, for posting the write-up and your code to actually solve it. Then Marek was actually... Am I skipping 2 slides? No, just 1. Perfect. Marek was the person who solved it as the... was the person who solved it as the first person. That doesn't make sense. As the first participant. And this is the bitmap, which... yeah, which is basically most of the maze and the part with the solution. Now, yeah, again, the MTR, or I'm sorry, I will not butcher your name again. I'm not going to read it. Also shared his code, their code. So and the map. So thank you for doing that. And I guess congratulations to the 3 people who did solve it and did share the solutions, and to Foxtrot Charlie for making these slides so I can save some time. Thank you for doing it. And that will be like that for today, I guess. I will let you know what's the topic for tomorrow's stream, because for the Polish stream, I guess early tomorrow, I guess ray tracing is there, but there will be no ray tracing tomorrow. I didn't finish it yet. And I will let you know what's the topic for the next English stream also, I think, by the end of the week. So that's about it. If you have any questions, I can answer, like, I guess 1 or 2 questions now, and we can call it a day. There's a question: is there any news about the result of a game competition? So no, I guess there's like a message about it here, but never mind. The game competition results will be in probably next week, and before next week I will post a gameplay video of all the games which came into the competition, which were 9 games again. Cool. Is there any other questions? I'm going to quickly look on the channel. No questions here. Okay, perfect. So thank you very much for being here. I think Mormus is going to stream like right after the stream or close to it, so do go to his channel and check it out. And thank you, and see you next week. I'm going to leave you with some music, but I guess without a challenge this time. Thank you to my moderators, and see you next week. Bye bye.